Okay, hello everyone. In this lecture series, we are discussing core paper 4, that is your waves and optics. We started the unit 1 and last class we discussed in detail about format principle with note. In this class, we are going to discuss reflection at plane interface. That means we have to prove the laws of reflections by using format principle. Okay, so let us start. This format principle that we have been discussed in detail in our last class. Now, today class we are going to discuss laws of reflections using format principle. Here, whatever I written, that is your note. You just download the note and prepare for your exam. First, we are going to go for first law, and we have to prove that first law. Then we are going to go for the second law. Okay. Here, first law, it states that the incident ray, the reflected ray, and normal at the point of incidence are in one plane. Just consider this figure. This is the plane mirror. On this plane mirror, one plane EFGH is a plane perpendicular to this plane mirror. Okay. At a source is present. Same thing I have been written over here. Consider a source is at A. Let us consider two rays. One is your AN and another is your AC. AN, A to N and A to C, coming from point A. These two rays are reflected from N and C. N and C, the corresponding reflected rays are NB and CB respectively. Here, NB, N to B and C to B. These are the two reflected rays. Here you can reduce the writing for in your exam. Okay. Here the point of incidence, that is your N, is the contact point of both plane EFGH and reflecting mirror. So this N point is the contact point for both plane EFGH, which is perpendicular to the mirror, and reflecting mirror. So here N is the point, is the contact point of this plane which is perpendicular to this plane mirror. Okay. From the figure, here you can see A to C is the larger distance than A to N. AC greater than that of the N. C to B path greater than that of the N to B path. Okay. This path greater than that of the this path, and this path AC greater than that of the AN. Same thing I have been written. Therefore, AC plus CB obviously greater than that of AN plus NB. Okay, here I written C point is only on the reflecting mirror. C point is only on the reflecting mirror. Here, C point is on the reflecting mirror. So only for that, AC greater than that of the AN and CB greater than that of the NB. Okay. Now, it will be considered that light travels by the path ACB, then it will contradict with format principle. Here, now, comma, if it will be, here I written, if it will be considered, अगर हम ऐसे सोचें, if it will be considered that light travels by the path A to C to B, then it will contradict with format principle, because according to format principle, light has to travel from one point to another by shortest path. So which one is the shortest path? If I am going to consider A, C, B and A, N, B, obviously A, N, B is the shortest as compared with A, C, B. So the correct or acceptable path according to format principle is your A and B. Okay, so if we are going to accept that A and B is your correct path, then C point is at the coincide. That means C point has to coincide on A. Here, what we considered another point C will be on the surface of the mirror, and we considered the ACB will be a possible path. No, it could not be possible according to format principle. So C point has to coincide on N. Hence, it is proved that incident ray, here incident ray AN, which is on this plane, EFGH plane. The reflected ray NB, this ray also on this EFGH plane, and normal NN dash, here NN dash, this is the normal to the reflecting surface or normal to the plane mirror at point of incident N are in one plane. At point of incident means at N all are in one plane. One plane means all are in this plane, which is perpendicular to this plane mirror. This is the first law what we have been proved. If this law asked in your exam for 2 mark, suppose you just draw the figure, write these 2 equations and write these 2 lines. These things I written for your understanding purposes. May you can write in your note. Now we are going to go for our next law, second law of reflection. It states that the angle of incidence is equal to the angle of reflection. That we have to prove by using Fermat principle. For that we consider this diagram. Let us consider AN and NB. AN, A to N, and N to B are the incident and reflected rays respectively, where N dash is the normal to the mirror N. This is your N and N dash, this one normal to the mirror, but here AN, NB, NN dash, all are present on this plane, which is perpendicular to this mirror. Indirectly I told the first law of reflection. Incident ray, reflected ray, normal at the point of incident has to be on the in one plane, whatever we have been discussed in our first law. Okay, so here in this diagram represents the same. I and R are the incident and reflected angles for this diagram, or for this ray. A to N is your incident, N to B is your reflected ray, and this I and R represents the incident and reflected angles. Now from figure it can be found that the total path, let us T, traveled by the ray is what? The total path, that means the rays came from A and reached at B, reflected at N. So total path will be A to N, AN, AN to B, NB. So total path is your AN plus NB. Now we are going to calculate AN and NB value from this figure. Consider this triangle AHN triangle and BGN triangle. Both are right angle triangle. This is your right angle, this is your right angle. Imagine this is the plane. On this plane another plane is perpendicular, like this, perpendicular. So obviously this angle will be 90, this angle will be 90 degree. So from this triangle AHN, AN, if I am going to consider Pythagoras theorem, AN, A to N, this distance will be AH square plus HN square root over, same thing I have been written, AH square plus HN square root over, and NB, N to B distance will be BG square, B to G distance plus N to G distance square, and it's a root over, right? Here AN is nothing but, sorry, now the total distance T will be equal to how much? AN plus NB, AN value written over here and NB value written over here. Okay, here AH we considered as H, small h, and H to N along x-axis, this much distance we have been considered as x. From H to G we considered as A. So obviously N to B G distance will be A minus x. Okay, so here instead of AH I have been written H, instead of HN, H to N, the value is your x, and BG, here B to G considered as L, small l. So instead of BG I written L square plus Ng. N to G value is your A minus X. So A minus X square. Let this is your equation number 1. According to Fermat principle, light has to travel from one point to another by shortest path. So if this is the total path that light travels from the point A to B after reflection N, that means it has to be the shortest path. That means T is your minimum or least. If it is so, then derivative of T with respect to X will be 0 because this is the minimum value. Okay, that means here An is the function of X, Nb also function of X. So obviously A to N, N to B, that is your T, is the function of X if it is so, and if it is minimum, then its value will be, the derivative with respect to X will be 0, right? That concept we are going to apply on this equation number 1. That means d by dx of equation number 1. Here equation number 1 or d by dx of t. T value is nothing but h square plus x square plus L square plus A minus x square root over equal to 0. So here take the derivative of this term with respect to x. The value will be how much? Here we know that derivative of root x will be 1 by 2 root x. Okay, suppose derivative of x square, derivative of suppose I am going to consider uh, 2x root over, suppose 2x root over with respect to x, it will be 1 by 2 root x. 2 root x means 2 root over of 2x, then derivative of 2x into 2, like that. So here h square plus x square root over is there, so the derivative with respect to x will be 1 by 2 root over of this one, written as such. Then derivative of this one, h square plus x square, h square is a constant, will be 0, x square derivative is your 2x. Okay, likewise the derivative of this term, L square plus A minus x square, L square and here L, A and L both are constant, so derivative of this term will be what? 1 by 2 root of same term, written as such. Then derivative of this one, L square plus A minus x square, L is the constant, it will be 0. Here A minus x whole square is your A square plus x square minus 2ax. So if I am going to consider the derivative of this one with respect to x, then the first term will be 0, second term will be 2x, and third term will be minus 2a. Or we can write 2 taken common, it will be sorry, here I, yes, it will be 2 into x minus a, or we can write minus 2 of a minus x. Same thing I have been written over here, minus of 2 into a minus x. Okay, will be equal to 0. You just simply solve by these two steps. Here this term is the minus, taken this side it will be plus. 2 got cancel. We found x by h square plus x square is equal to here here a, it will be by mistake I written b. This is your a. I'll be correct whenever I'll upload this note, I'll correct it. A minus x by this term, because 2 got cancelled, this one. Okay, now here you can see this is your a. Here this one value, if I'm going to search in this triangle, if I'm going to consider this triangle AHN, sine, suppose I'm going to consider sine I, here this is the theta, sine I theta will be equal to this distance HN by AN, right? HN value is nothing but your x, and AN value is nothing but your h square plus x square root over as such I written. So this is nothing but your sine I. Here I written the same by considering triangles, right angle triangles AHN and BGN. Now you just consider BGN triangle. Here you just try to find out sine R. Here if I'm going to consider sine R, here this is the R. See, if this angle is your I, obviously this angle will be I. If this angle will be is your R, this angle also will be R, that we know. Okay, or you can found easily, no problem. Here sine R will be equal to how much? Here this distance, that is your ng minus nb, ng minus nb. Ng is nothing but your a minus x, nb is nothing but what? This term, L square plus a minus x whole square root over. So here this term is nothing but your sin r, right? This is your sin r. So here if sin I equal to sin r, that means I equal to r. That means this incident angle will be your reflected angle. That means angle of incidence is equal to angle of reflection. Okay. So here may you confuse that how this angle is equal to this angle. It is very easy. Here you can see this is your what, 90 90 plus, sorry, if I'm going to consider this angle is your this angle is your how much? See this angle is your 90, so this angle is your 90 minus I, and this angle is your 90. Okay, so obviously this angle will be I, because this angle plus this angle plus this angle is your 180 degree. Okay, so obviously this angle will be 90 degree. Likewise this angle, if r, this angle will be also r, because this is your 90 degree. Okay, here we proved first law and second law of reflection by using Fermat principle. Here I am going to stop this lecture. In our next lecture or next class, we are going to discuss laws of refraction by using Fermat principle. Thank you so much for watching this video. Thank you.